Hello there, and welcome to Science to Fall Asleep To. I'm glad you've arrived, perhaps at the end of a long day, perhaps at the quiet beginning of your rest. This space is for you to unwind, to let your breathing slow, and to drift gently into a rhythm that carries you farther than sleep alone. Tonight, and on the nights to come, we'll wander through 100 truths about the universe. They are not the kind of truths that demand urgency or noise. They are quiet, ancient facts, stitched into the fabric of existence, waiting patiently to be noticed. You have nothing to do now but listen, imagine, and rest. And while you're settling in, before your eyes grow too heavy, I'd love it if you gently tapped subscribe or pressed the little hype button YouTube recently added. It's a small click, but it helps keep these experiments and explorations orbiting out into the algorithm. You can also leave a comment telling me where you're listening from and what time it is in your corner of the night. It's oddly fascinating to see where people are drifting off with us, scattered across the world like stars across the galaxy. As you settle into stillness, picture yourself not bound to the weight of the earth, but floating free, carried softly on unseen currents. Above you stretches a canvas of stars, not as cold pinpricks, but as a vast river of light, glowing steadily with the memory of billions of years. You may already sense the calm that comes from realizing how small our troubles are in the context of such immensity. This is the feeling that guides us. Curiosity that soothes instead of stirs, wonder that rests instead of overwhelms. We are going to step slowly, fact by fact, into a universe older than time as we measure it, wider than any horizon, and stranger than we can ever fully imagine. The universe is not here to test us. It is not waiting for our approval or our fear. It is simply here, as it has been for nearly 14 billion years, unfolding in silence. Yet within that silence are stories. Galaxies swirl and merge, stars flare and fade, planets circle quietly in the dark. These stories are not fiction. They are as real as the air you breathe, the iron in your blood, the ground beneath your feet. And though they are vast, they belong to you as much as to anyone. You are already a participant, a collection of atoms formed in stellar furnaces, listening now with a consciousness that itself is part of the cosmic unfolding. Perhaps you've tried before to imagine infinity, only to find the thoughts slipping through your grasp. That is natural. Our minds were shaped by seasons and days, not by billions of years or endless distances. But here, you don't need to solve infinity. You only need to drift through glimpses of it, each fact like a lantern carried past you in the dark. Some may make you pause with awe, others may pass by quietly, leaving just a trace of wonder. Together, they weave the beginning of an understanding not complete, never complete, but enough to remind you of your place in something wider than the span of your own lifetime. As you listen, let yourself notice the rhythm. 100 facts will become 100 moments, spread across chapters like constellations across the night sky. They will not shout. They will not rush. Instead, they will guide you gently. Galaxies forming like clouds, stars collapsing like whispered sighs, planets spinning unseen, forces invisible yet everywhere. Even as you rest, they continue, steady and indifferent. And yet, knowing about them brings a kind of peace, the way hearing distant ocean waves can calm you even if you never step onto the shore. Think of this first chapter as an opening door. Beyond it lies the cosmos in its many layers, the seen and unseen, the measured and the mysterious. There will be facts about light and time, about matter we cannot see and energy we cannot touch. There will be truths about distant worlds that circle suns we will never visit, and about particles so small they pass through your body by the trillions every second. Some facts will be familiar, like old friends you've heard of but never lingered with. Others will be strange, carrying names or numbers that feel almost unreal, and yet all of them are threads in the same vast fabric. You don't need to hold them all at once. You don't need to remember them perfectly. Each one is simply here to spark a small moment of recognition. The universe is bigger, older, and more intricate than you knew a moment before. That recognition does not need to startle. It can be like a cool wind moving through your thoughts, clearing space for quiet wonder. The universe is filled with violence and brilliance, but here we approach it gently. Supernova that shatter stars become, for us, reminders of how endings give way to beginnings. Collisions between galaxies become metaphors for transformation rather than destruction. Even black holes, the most mysterious objects we know, become not terrors, but symbols of silence, regions where even light chooses to rest. This is the tone we will carry, one of calm exploration, where even the most dramatic truths are softened into something contemplative. So, let go of the weight of the day. Let go of the lists and the noise, the demands that call for your attention when the sun is up. You've stepped into a place where the only thing expected of you is stillness. You are free to imagine stars being born without needing to chart them, to picture galaxies colliding without needing to measure them, to hear about cosmic rays passing through you without needing to stop them. Knowledge here is not a task but a lullaby, not a lecture but a slow turning of pages in the dark. If you close your eyes, you might picture yourself drifting outward from Earth, past the moon, past the planets, past the edges of our solar system. As you travel, the world behind you becomes smaller, and the silence around you grows deeper. Stars begin to cluster into hazy rivers, and the Milky Way stretches wide, not as a stripe across the night, but as a full spiral, radiant and immense. Beyond it lie other galaxies, billions upon billions, stretching into the distance until they blur into a faint background glow. And even beyond those, the faint afterglow of the universe itself, the remnant whisper of its beginning. This is the scope of what lies ahead. 100 facts, 100 steps into the greatest story we know, told not with urgency, but with the patience of the cosmos itself. Each one will unfold in its own time, like constellations appearing one by one as the night deepens. By the end, you may find yourself looking at the sky differently, or you may find yourself simply more at ease, your thoughts expanded and yet lighter, your place in the universe no longer something to grasp, but something to rest within. For now, that is enough. You are here, the universe is here, and together you will drift. Let your breath slow, let your body sink into rest, and let your mind open like a window onto the stars. Tonight is only the beginning. When people look up at the night sky, it is natural to imagine that there must be a center, some fixed point around which everything turns. Our lives are built on centers, a hearth in a home, a sun in a solar system, a town square in a city. We are used to circles that have hearts, to orbits that have anchors. And yet, when it comes to the universe itself, there is no single center. There is no heart you could fly to, no throne of creation where everything began and still points back to. The universe is not built like a wheel with a hub. It is built like something stranger and more diffuse. It expands everywhere, from every direction, all at once. To understand this, imagine rising bread dough, swelling in an oven. If you place raisins in the dough, each raisin will see all the others drifting away as the dough expands. None of the raisins is the center of the expansion, and yet from each raisin's perspective, it seems as if all the others are fleeing outward. Our galaxies are like those raisins, glowing clusters of stars carried on the swelling fabric of space. There is no privileged raisin, no hidden core of the loaf. The expansion is not happening into anything outside of the dough. It is the dough itself, the space between raisins that grows. In the first fraction of a second after the Big Bang, something extraordinary occurred. The universe did not simply drift open like a flower. It inflated, faster than even light could cross a room. This was not an explosion in the ordinary sense, flinging debris into emptiness. It was the sudden stretching of space itself, everywhere at once. That moment set in motion a cosmos without edges, a cosmos that has no outer shell to bump into and no center to retreat toward. The explosion metaphor tempts us, but it misleads. There was no blast point in some empty void. There was only expansion, uniform and relentless, filling itself. Think of it as lanterns on a dark river, set adrift at the same time. Each lantern sees the others drifting away, and from each lantern's vantage point, it feels as though all the others are retreating from it. But in truth, there is no single lantern at the origin. The whole river carries them outward, and what they perceive as motion away from them is simply the current unfolding. In the same way, galaxies are lanterns cast into the flow of space. They drift apart not because they are actively moving through pre-existing emptiness, but because the river itself, the space they rest upon, expands beneath them. This truth unsettles because it denies us the comfort of center and edge. If there is no center, there is also no boundary. The universe does not end in a wall of fire or a great stone cliff beyond which nothing lies. It simply continues, in all directions, beyond the farthest light we can see. What we call the observable universe is limited not by walls, but by time. Light takes billions of years to travel, and so we can only see as far as light has had time to reach us. Beyond that horizon, the universe goes on, perhaps forever, perhaps not. But if there is an edge, it lies so far beyond reach that for us it might as well not exist. Astronomers map galaxies and find that, on the grandest scales, they scatter evenly, like seeds across soil. From our perspective, it looks like everything is racing away, more distant galaxies rushing faster than nearer ones. This is called Hubble's law, and it is one of the clearest signatures of expansion. Yet the same would be true if we stood in any other galaxy. From their vantage point, the rest of the cosmos would also be streaming outward. Every galaxy is a center in appearance, but none is in reality. The trick is that expansion has no anchor point. It has only relationship, only relative motion, only the mathematics of stretching. It is tempting to ask, if the universe is expanding, what is it expanding into? But this question arises from our everyday sense of space, a sense that presumes an outside. A balloon expands into the room around it. A wave spreads across a pond. But the universe is not inside anything else. Its expansion is not a growth into pre-existing emptiness. It is a growth of the fabric of space itself. The balloon does not need an outer chamber to exist. Its surface simply grows larger. In the same way, the universe's surface, though in more dimensions than we can picture, simply unfolds. Imagine standing under a sky where every star is a lantern tied to invisible strings. Over time, those strings lengthen. Each lantern drifts farther, and the pattern changes. You could choose any lantern to call the center, and from that point of view, the rest would seem to pull away. But the true story lies not in the lanterns themselves, but in the invisible cords that connect them. Expansion is not about flight. It is about stretching. This means we live in a cosmos where motion is everywhere, where the background itself carries galaxies apart. Even as you sit still, even as you rest, the space between the Milky Way and its neighbors stretches like taffy drawn gently outward. The galaxies themselves remain bound by their own gravity, but over vast distances, expansion wins. Clusters recede, voids grow larger, and the pattern of galaxies drifts farther apart. It is a slow unraveling that never began from a single visible point, but from everywhere at once. Somewhere in this truth lies a quiet comfort. We are not at the edge of anything. We are not near the rim of some enormous wheel or the end of some glowing chain. We are simply inside, as much as any other point is inside, carried on the same currents as all else. To ask where the center is to misunderstand the shape of the river. There is no raft tied to the middle. The river is everywhere, flowing endlessly, and we are within it. The absence of center also changes how we see ourselves. It means Earth is not privileged, nor is the Milky Way, nor even our local cluster of galaxies. All are part of the same story, equally central and equally peripheral. Every point in the universe carries the illusion of being the heart. Every observer sees the same outward drift. In this way, the cosmos levels us, humbles us, and invites us to belong without superiority. And so we drift, not from a center and not toward an edge, but outward in every direction, our galaxies like glowing lanterns on a swelling tide of darkness. There is no need to find the heart of it all, because the heart is nowhere and everywhere at once. What matters is that we are within it, part of the same unfolding, carried by the same invisible stretch. The universe expands, and we expand with it, not as exiles from a center, but as participants in a motion that belongs to no single place. In this way, the cosmos teaches us something profound. There is no single point of beginning to return to, no privileged vantage point to claim as our own. There is only motion, only change, only the quiet stretching of space. And within that motion, we rest, drifting without edges, without center, without end. When you look at the night sky, it feels as though the universe reveals itself in a flood of light. Stars crowd the heavens, galaxies shimmer like faint clouds, and the Milky Way spills across the darkness in a pale river. It seems vast, luminous, and infinite. And yet, what you are seeing is only a sliver of reality, a fraction so small it is almost laughable. All the light you can ever behold, every star, planet, nebula, and glowing cluster, makes up less than 5% of what exists. The rest, the overwhelming majority, is invisible. It is not hidden by distance or dust or faintness. It is hidden because it does not shine at all. Scientists call it dark matter and dark energy, though those names are more admissions of ignorance than true explanations. Dark matter reveals itself only through gravity, a silent pull that holds galaxies together and keeps their stars from flying apart. Dark energy is stranger still, a force that seems to push, not pull, accelerating the universe's expansion like a breath that will not slow. Together they dominate the cosmos, composing 95% of all existence, while we and our stars are left as the faint afterthoughts of creation. We are the 5%, drifting in a sea of the unseen. Imagine walking into a grand symphony hall. The orchestra is playing, but your ears can catch only the faintest notes from the violins. You strain to hear the full harmony, but most of it is beyond your reach, as though the music itself were cloaked. This is what it means to live in a universe that is mostly invisible. We are surrounded by a hidden composition, intricate and powerful, but we hear only its echo. The stars are the faint instruments we can detect, glowing and burning. But the deeper song belongs to something quieter, darker, and far larger than us. When astronomers first tried to measure the rotation of galaxies, they expected the outer stars to move more slowly than the inner ones, just as planets farther from the sun orbit more slowly. But what they found defied Newton's predictions. Stars at the edges of galaxies raced along almost as quickly as those near the core. By rights, they should have been flung into space. The only explanation was that something unseen was binding them, an invisible mass outweighing all the visible stars. Thus, dark matter revealed itself not by being seen, but by holding galaxies in its grasp. It is the hidden scaffold upon which the universe is built. But even dark matter does not complete the story. As measurements grew more precise, astronomers discovered that galaxies are not simply drifting apart with the momentum of the Big Bang. They are accelerating, speeding away from one another, as if driven by an unseen wind. This mysterious expansion is credited to dark energy, a name that hides as much as it admits. Whatever it is, it makes up nearly 70% of the universe, dwarfing both dark matter and the matter we can see. If dark matter is the scaffold, dark energy is the current, pushing the universe wider, faster, farther, with every passing moment. Think of the universe as a great ocean. The stars and galaxies are ships floating on its surface, lit by lanterns that we can see from afar. But beneath the waves lies the true mass of the sea, vast and unseen. Currents move invisibly, shaping the course of every ship, though no captain can command them. We are not just passengers on those ships, we are built from them. The atoms of your body, the iron in your blood, the oxygen in your breath, all of it belongs to the rare visible part of the cosmos. You are made from the glowing crumbs, while the unseen banquet lies beyond reach. This reality humbles and unsettles. We imagine ourselves to live in a universe of light, but we reside in shadows. Everything we know, every civilization, every star, every story, rests on an invisible foundation. If you could wave away all dark matter, galaxies would unravel like loose threads, stars scattering into emptiness. If you could silence dark energy, expansion itself might stall, and the universe could collapse back into fire. The hidden 95% is not an accessory to the universe. It is its very stage. We are the brief lights flickering upon it. And yet, there is something beautiful in this mystery. The fact that we cannot see it does not mean we cannot feel its presence. Just as you cannot see the wind, but you watch it ripple the trees, so too can we watch dark matter curve the path of starlight and bend the shapes of galaxies. We can map the invisible by its footprints. Just as you cannot hear every note of a symphony, but still feel the music in your bones, so too can we sense that the universe hums with forces beyond our vision. We are notes in a hidden symphony, rising and falling with harmonies too vast for our ears. The stars are the visible melody, but the bass line, the rhythm, the deeper chords belong to something silent. To live in the universe is to know that most of what carries us cannot be touched, cannot be seen, cannot be grasped directly. And still, we are shaped by it. We orbit within it. We breathe because of it. It might seem lonely to live in such ignorance, but perhaps it is also a gift. The universe keeps some of its secrets veiled, inviting us to wonder. If everything were visible, perhaps we would cease to search, cease to imagine. But with so much left unseen, the story is still open, still unfolding. Dark matter and dark energy remind us that our understanding is provisional, that humility is as essential as curiosity. The cosmos does not yield itself easily. It whispers, and we lean closer. Tonight, as you close your eyes, remember that the darkness around you is not empty. It is full, brimming with hidden weight and hidden motion. Every star that twinkles does so against a canvas richer than we can fathom. You are a flame lit in a universe of shadows, a small flicker carried on an invisible tide. And though you cannot see it, the unseen holds you, steadies you, and carries you ever outward on the current of expansion. The universe has a birthday, though it is not the kind of moment we can mark with candles or calendars. It began about 13.8 billion years ago, when space itself expanded from something unimaginably small and hot into the wide cosmos we see today. That number is so vast it resists comprehension. Billions of years stretch past the limits of ordinary thought, making the history of our own lives, or even the history of humanity, seem like faint brushstrokes on an endless canvas. And yet, in its enormity, there is something calming. The age of the universe tells us we are held within a story much older than ourselves. A story already ancient before the earth was formed, before the sun lit, before the faintest outline of what would one day be us came into being. When you think of your own life, perhaps you measure it in decades, or with the span of generations you have known parents, grandparents, children, grandchildren. The sweep of human history itself is measured in thousands of years. Our oldest ruins are 10,000 years old at best. Our oldest written words perhaps 5,000. Civilizations rise and fall across centuries, and to us, that feels vast. Yet even if we compressed all of human history, every empire and language and story, into a single volume, it would be less than a page in the age of the cosmos. Earth itself is about 4.5 billion years old. That feels ancient. And it is, a time long enough to build mountains and break them down, long enough to shape continents, oceans, and the fragile layers of atmosphere where we live. But when Earth was born, the universe had already been unfolding for more than 9 billion years. Galaxies had already formed, stars had burned and died, and the elements that would one day become our oceans and our bones were already being forged in other suns. Our world arrived not at the beginning, but in the middle, as if we were born into a novel already deep into its chapters. One way to understand this vastness is to shrink the entire history of the universe into a single year, a cosmic calendar where the Big Bang happens on January 1st, and the present moment is the last second of December 31st. On this scale, our Milky Way galaxy begins to form around May. The Sun and Earth appear in early September. Life begins to stir by the middle of that month, tiny cells drifting in ancient seas. Dinosaurs walk across the land in late December, and only in the final hours of the final day do humans arrive. All of recorded human history, the building of pyramids, the writing of poetry, the rise of nations, takes place in the last few seconds before midnight. Our lives are flickers inside flickers, breaths inside a single tick of the clock. It is easy to feel small when faced with numbers so immense. Compared to 13.8 billion years, what is a century? What is a lifetime? And yet, within this scale, there is a strange comfort. We do not have to carry the weight of eternity. Our role is not to live across billions of years, but to inhabit our brief span fully, to be the momentary witnesses of an ancient story that continues long after us. The brevity of our lives does not diminish them. It sharpens them, giving every glance and breath a kind of fragile brilliance. The age of the universe also reveals that we are not just products of one moment, but inheritors of everything that came before. The atoms in your body are older than the Earth itself, forged in the cores of stars that lived and died long before our planet existed. Some of the hydrogen in the water you drink has been around since the very first seconds after the Big Bang, drifting for billions of years before finding its way into rivers and oceans. You are not only part of this 13.8 billion year old universe, you are made from its earliest remnants. You are ancient, even as you are new. Astronomers use light itself to measure this age. The faintest glow we can see, the cosmic microwave background, is a kind of afterimage of the Big Bang, light that has been traveling for almost the entire history of the universe. It reaches us as a quiet, uniform haze, like the embers of a great fire that burned long ago. By studying its patterns, scientists trace back to those earliest moments, measuring the expansion of space, the birth of galaxies, the rhythm of time itself. To look into that glow is to see not just distance but age, the oldest memory the universe has left us, and what lies ahead. If the past stretches back 13.8 billion years, the future may stretch much farther still. Galaxies will continue to drift apart, stars will continue to burn and fade, and new generations of light will rise. The universe does not rush. It moves on timescales that are patient beyond our grasp. Our presence within it is not lessened by our brevity. It is made luminous by it. For we are the ones who look back and measure, who wonder, who place ourselves in the story of a cosmos that has seen far more than we can imagine. As you let your mind drift with these thoughts, consider that you are resting inside a universe almost 14 billion years old. Every breath you take is carried on air that has existed for nearly a third of that span, recycled through oceans and forests and the long churning of Earth. Every moment is a point on a line that began long before us and will continue long after. You do not need to hold it all. You only need to be here, awake enough to know that you are part of something so vast it cannot be measured in years alone. The age of the universe is not only a number, it is an invitation to humility, a quiet reminder that we walk briefly across a stage that has been set for eons. It tells us we are latecomers, but also that we are here at all, which is its own wonder. Tonight, as the stars turn above you, remember that they are not only lights in the sky, they are ancient companions, older than Earth, younger than the universe, sharing with you this fleeting chapter of an endless story. You are not separate from the 13.8 billion years that came before. You are its continuation, its witness, its latest verse written in light. When you look up at the night sky, what you see is only the beginning. The stars overhead seem countless, scattered like diamonds on black velvet, but they are just a whisper of the greater whole. Each star belongs to a vast family of stars, dust, and dark matter, bound together in a structure we call a galaxy. And galaxies are not rare. They are everywhere, scattered through the universe in numbers too great to fathom. Astronomers now believe there may be over 2 trillion galaxies in the observable cosmos, each containing billions or even trillions of stars. It is almost impossible to hold such numbers in the mind, but you don't need to. All you need to know is that the night sky is not empty but overflowing, brimming with more worlds than you will ever see. Imagine the universe as a vast ocean. Galaxies are the islands floating upon it, glowing continents of light scattered across the dark. Some are close to one another, grouped in clusters like archipelagos, drawn together by invisible currents of gravity. Others drift more quietly, alone in wide cosmic seas. From our vantage point on Earth, they are so far away that most appear only as faint smudges or hidden entirely to the naked eye. But with telescopes, the truth comes into view. The ocean is crowded with islands, and the horizon stretches farther than any map can reach. Not all islands are the same, and not all galaxies are alike. Some are graceful spirals, their arms curling outward like luminous whirlpools. These galaxies are places of constant creation, with new stars forming in the dense lanes of dust and gas that lace their arms. Others are elliptical, vast ovals of older stars glowing with a steadier light, their shapes less structured but no less grand. Then there are irregular galaxies, distorted or chaotic, their outlines shaped by collisions or gravitational encounters. They may not look symmetrical, but they are still homes of countless suns, still lanterns in the dark. Each galaxy is a story written in stars, its shape a reflection of its history, its scars, its growth. Our own Milky Way is a spiral, one of hundreds of billions spiraling through space. It looks ordinary compared to others, not the largest or brightest, yet to us it is everything. But when you zoom out far enough, it becomes only one among many, one glowing swirl in a sea without end. Even Andromeda, our nearest large neighbor, 2 million light-years away, is just a single island in this cosmic archipelago. Beyond it lies Virgo, a cluster of thousands of galaxies, and beyond that still larger clusters, filaments, and webs stretching across space like rivers of light. The sheer number is difficult to grasp, but it can also be soothing. You are not adrift in emptiness. You are afloat in a universe rich with light, a universe where galaxies shine like lanterns scattered endlessly across the night. They are too far for us to visit, but not too far for us to know. Their light reaches us across unimaginable distances, carrying stories of what they were like millions or billions of years ago. Every galaxy we see is also a memory, a glimpse into the past written in starlight. When astronomers first pointed the Hubble Space Telescope at what seemed like an empty patch of sky, the size of a grain of sand held at arm's length, they expected to see only a handful of distant galaxies. Instead, they found thousands crammed into that tiny view. Every dot was another island of light, each with billions of stars, each with the possibility of planets and stories of their own. If such abundance could be revealed in so small a slice, then imagine the whole sky. Imagine the ocean stretched in every direction, full of luminous islands beyond count. Galaxies do not remain unchanged. They move, they collide, they merge. Sometimes two spirals will drift together, their arms entangling, their stars thrown into new orbits, their gas compressed into bursts of creation. Over time, they may form a single, larger galaxy, a new island stitched together from the old. These encounters are not violent in the way we imagine, for stars are so far apart that collisions are rare. Instead, the galaxies bend, twist, and reshape, like two waves colliding and forming a new pattern. What seems permanent from afar is actually in motion, an ongoing dance that unfolds over billions of years. In the vastness of the universe, galaxies form part of an even greater pattern. They are not scattered randomly, but arranged in threads and filaments, weaving a cosmic web. Along these invisible strands, galaxies gather like beads, leaving vast dark voids between them. From a distance, the structure of the universe resembles a great lacework or a river delta frozen in light. Our galaxy is one tiny part of this web, bound by gravity into a community of neighbors, moving slowly together through time. And yet, in all this immensity, here you are, on a small planet circling an ordinary star, in a spiral galaxy that is one among trillions. It could make you feel insignificant, but it can also bring calm. You are not required to be infinite. You are simply part of an infinity that already exists. The galaxies shine whether we watch them or not. They have turned for billions of years before us and will continue long after, scattering their light across the ocean of space. To lie beneath the night sky and know this is not to feel lost, but to feel surrounded, gently, by endless islands of light. You may never see most of them, but that is not the point. They are there, and you are here, and the distance between is part of the wonder. You do not need to touch every star to belong to the universe. You already do. Like every galaxy, you are a flicker of light in the dark, a note in a hidden symphony, a moment of awareness floating within an ocean too vast to name. And as you rest, know that the galaxies drift quietly, patiently, their light crossing billions of years to reach your eyes. The ocean is wide, but you are already within it. Every star you see shining in the night sky has a story, and like all stories, it has a beginning, a middle, and an end. Stars are not eternal. They are born, they live, and they die, carrying with them the drama of creation and destruction that makes the universe what it is. To us, they seem constant, glowing silently as if they have always been there and always will be. But each one is a flicker in time, burning through its fuel, changing shape, and eventually fading or exploding. The light we see is not just brightness, it is life unfolding on a cosmic scale. Stars begin in darkness, deep within immense clouds of gas and dust, hidden from our eyes. Gravity begins to tug. Hydrogen atoms draw closer together, slow at first, then faster as the cloud collapses inward. The gas cools and gathers, forming dense knots inside the larger cloud. These knots, called protostars, grow heavier as they pull in more and more material. Pressure builds, temperatures climb, and what was once invisible becomes a glowing ember. When the core grows hot enough, nuclear fusion ignites, and a star is born. From the cold and silent womb of a nebula, a new sun flares into being, and another light enters the universe. For most of its life, a star exists in what astronomers call the main sequence. Here, it burns hydrogen into helium in its core, releasing energy in the form of light and heat. The balance between gravity pulling inward and fusion pushing outward keeps the star stable, and it shines steadily for millions or billions of years. Our own sun is a main sequence star, ordinary in size, ordinary in age, yet extraordinary to us because it sustains all life on Earth. It has burned for about 4.6 billion years and will continue to shine for billions more, holding steady in this long middle chapter of its life. But even stars grow old. Eventually, a star's hydrogen fuel begins to run low. When that happens, its core contracts, heating further, while its outer layers expand. The star swells to many times its original size, becoming a red giant. Its surface cools, giving it a deep crimson hue, but its heart burns hotter than ever, fusing heavier elements like carbon and oxygen. For a star like our Sun, this stage is the last great act of its life. The outer layers will eventually drift away into space, forming a glowing shell of gas called a planetary nebula, while the core shrinks into a dense, white-hot remnant known as a white dwarf. Over billions of years, this ember will cool, growing dimmer until it is no more than a shadow of the brilliance it once held. Larger stars live more violently. When their hydrogen runs out, their cores collapse with greater force, fusing heavier and heavier elements in quick succession. They swell into supergiants, unstable and immense, until finally their cores can no longer withstand the pressure. In that moment, the star dies in a supernova. The explosion is so powerful, it can outshine an entire galaxy, releasing more energy in seconds than our Sun will produce in its entire life. It is an end, but it is also a beginning, because the blast scatters newly forged elements into space: iron, gold, oxygen, calcium, everything that will one day form planets, oceans, and living beings. What remains after such a cataclysm depends on the size of the star. Some collapse into neutron stars, impossibly dense spheres where matter is packed so tightly that a teaspoon of it would weigh billions of tons. Others collapse further still, forming black holes, regions of space where gravity is so strong that not even light can escape. These remnants are not the end of the story. They are markers of transformation, reminders that nothing in the universe is wasted. The matter flung into space from a dying star becomes the seedbed for new stars, new systems, and eventually, new life. Every atom in your body was once part of such a cycle. The iron in your blood was forged in the core of a star that died long before the Earth existed. The calcium in your bones, the oxygen you breathe, the carbon that forms the structure of every cell, all of it was created in the heart of a star and scattered into space by its death. When you breathe, when you move, when you think, you are carrying the memory of ancient stars within you. Their lives did not end in vain. They continue, quietly, through you. This cycle of birth, life, and death repeats endlessly across the cosmos. Stellar nurseries light up with newborn suns. Main sequence stars glow steadily, like steady heartbeats. Red giants swell and fade. Supernovae ignite the darkness with violent brilliance. White dwarfs cool slowly into silence. Neutron stars spin like cosmic lighthouses. Black holes lurk unseen, shaping space itself. And through it all, the universe renews itself, endlessly recycling matter, endlessly reshaping. It is easy to think of stars as distant and impersonal, but when you understand their lives, they become familiar. They are not just pinpricks of light, but fellow travelers in time, living beings on scales far beyond ours, but still bound by beginnings and endings. Their lifespans may stretch for billions of years, yet their arcs are as fragile as ours. Rise, flourish, fade. To watch the stars is to watch life itself unfold in another form, vast and luminous, yet not so different from our own stories. And so, as you rest under the night sky, know that you are not only gazing at distant suns, but at the echoes of their lives. You are seeing the past written in light, the present unfolding in quiet radiance, and the future already prepared in the elements they cast into space. Stars are not eternal, but neither are they ever truly gone. Their ashes become our breath, their remnants shape the galaxies, and their light continues long after they have faded. You too are part of that cycle, carried gently by a universe that creates, destroys, and creates again. In the death of stars lies the promise of everything. There are places in the universe where the ordinary rules of light and matter come undone, where gravity is so strong that nothing, not even light itself, can escape. These are black holes, regions of space that defy both our senses and our understanding. To imagine one is to imagine silence given form, an absence so complete that it becomes a presence in itself. They are not glowing like stars, not drifting like planets, but waiting, hidden, bending the universe around them. They are at once the simplest objects in physics and the most mysterious. A black hole begins when mass is gathered so densely that gravity overwhelms everything else. For a star many times larger than our sun, the end of its life can trigger such a collapse. When the core can no longer resist the pull inward, it falls without end, compressing into something infinitely dense, what physicists call a singularity. Around this singularity lies the event horizon, the invisible boundary where escape becomes impossible. To cross it is to pass into a region forever sealed off from the universe we know. No message, no light, no touch returns. It is not a surface but a threshold, the point of no return where space itself falls inward. From the outside, we cannot see a black hole directly. It offers no reflection, no glow, no flicker, yet its presence is undeniable. Matter falling toward it swirls into a disk of fire, heating to millions of degrees as it spirals closer. This disk shines brilliantly in X-rays and gamma rays, a luminous farewell before the plunge. Stars orbiting nearby trace invisible paths around an unseen anchor, their motions betraying the mass hidden in the dark. Even light bends, curving around the hole, distorting the images of background stars in ghostly rings. Black holes are paradoxes of invisibility and evidence. They cannot be observed, and yet we know them by everything they change around them. Not all black holes are alike. Some are born from dying stars, small by cosmic standards, only a few times the mass of the sun. Others grow far larger, swelling as they consume gas, dust, and even stars that wander too close. At the centers of galaxies lurk the giants, supermassive black holes weighing millions or even billions of suns. Our own Milky Way harbors one called Sagittarius A, quiet now, but immense, a conductor of stellar orbits at the galactic heart. Across the universe, other supermassive black holes blaze as quasars, feeding so greedily that their accretion disks outshine entire galaxies. And yet, for all their violence, black holes can be eerily still. If no matter falls in, they remain dark and silent, invisible against the backdrop of space. They could drift beside us unnoticed, revealed only by the trembling of nearby stars. They are both destroyers and shadows, gaping wells that consume and yet carry nothing of themselves outward. To think of them is to imagine a cosmic doorway, one that swallows everything but never opens again. The physics of the singularity stretches imagination to its limit. Within that point, mass is crushed into infinite density, and space and time themselves collapse. General relativity, Einstein's great theory of gravity, predicts it, but at the singularity, the equations cease to make sense. It is a place where our knowledge fails, a reminder that the universe still holds secrets beyond our reach. Some scientists suspect that quantum mechanics may offer answers, that the smallest scales of reality may soften the infinities we cannot yet resolve. Until then, the singularity remains hidden behind the horizon, a mystery at the heart of every black hole. To fall toward a black hole is to enter a world where time and space warp beyond recognition. To a distant observer, your fall would appear to slow, frozen at the edge of the horizon as your light stretched and dimmed into red. But to you, the fall would continue smoothly, faster and faster, until nothing remained but the singularity ahead. Inside, space itself is drawn inward, carrying everything with it. It is less like falling into an object, and more like being swept into the current of a river, one that flows only one way, with no turning back. Despite their darkness, black holes illuminate the universe with strange beauty. The jets of plasma they launch at near light speeds, the arcs of distorted starlight they create, the brilliant flare of matter torn apart at the edge, all are signatures of their unseen presence. In 2019, humanity caught its first glimpse of one, not directly, but through the shadow it cast in glowing gas. The image of the black hole in Galaxy 87 was not just a scientific triumph, but a moment of awe. For the first time, we saw the outline of an absence, the dark heart of a galaxy etched against light itself. And perhaps the most haunting truth of all is this: black holes are not distant curiosities. They are part of the fabric of the universe, scattered across galaxies, shaping their growth, stirring their stars, and binding them together with hidden gravity. Without them, galaxies might not form as they do. Without them, the cosmos would be a quieter, simpler, less dynamic place. Black holes, in their silence, give structure to the universe. We drift in a cosmos that holds these invisible wells all around us, some small, some colossal, some sleeping, some blazing with furious light. They are reminders that the universe is not entirely gentle, that it holds within it both creation and annihilation, both silence and fire. They are not monsters to fear, but mysteries to respect, teachers of humility in a cosmos that still exceeds our grasp. To look into the night sky is to look into a universe laced with unseen depths. Somewhere, beyond our sight, space folds into itself, and light itself is caught. Black holes are not just endings, they are also beginnings, shaping galaxies, seeding the cosmos with energy, and whispering of physics we do not yet understand. In their shadows lies not just destruction, but the promise of discovery, the reminder that even the darkest places are part of a greater whole. And as we float through the universe, we are drawn not just to the stars that shine, but also to the spaces where light cannot go. It is there, in the silence of singularities, that the cosmos keeps some of its most profound secrets. When a massive star dies but stops short of becoming a black hole, something extraordinary remains. The core collapses under its own weight, crushing protons and electrons into neutrons, creating an object so dense that a single teaspoon of its material would outweigh mountains. This is a neutron star, a relic of a supernova, compact beyond imagination, no larger than a city yet more massive than the sun. It is both a monument to destruction and a strange continuation of life. Out of the ashes of a stellar death comes a body unlike anything else in the cosmos. The density of a neutron star is almost impossible to picture. Imagine compressing the mass of the sun into a sphere only about 20 kilometers wide. Gravity there is so intense that atoms themselves cannot remain intact. The boundaries that normally separate particles dissolve, and matter becomes a sea of neutrons packed shoulder to shoulder, squeezed into a state of matter unknown on Earth. If you tried to set a single teaspoon of neutron star material on the ground, it would fall straight through, drilling to the planet's core in an instant. Unstoppable, unimaginably heavy. They are the most solid things in existence, yet they are born from violent collapse. Despite their size, neutron stars are not silent. Many spin at staggering speeds, hundreds of rotations every second, dragging powerful magnetic fields with them. These fields funnel radiation into beams that sweep across space like the beams of a lighthouse. When one of these beams passes across Earth, we see a pulse of light, regular and steady, a signal that repeats with astonishing precision. These stars are called pulsars, and they are some of the most accurate clocks in the universe. Their ticking is not mechanical, but cosmic, born of rotation, magnetism, and gravity wound together into order. Astronomers first discovered pulsars in 1967, puzzled by the exact rhythm of the signals. At first, they even wondered if it might be communication from distant intelligence, so perfect was the timing. But it soon became clear that these signals were natural, the heartbeat of collapsed stars still spinning in the dark. Each pulse tells us the rotation of the star, and some are so steady that they rival the precision of atomic clocks. In the silence of the universe, they tick, not with sound but with flashes of energy, marking time across light years. Pulsars are not merely curiosities. They are tools, beacons that let us measure distances, probe the fabric of spacetime, and even search for gravitational waves. By studying their rhythm, scientists can detect the faint distortions caused when massive objects collide elsewhere in the cosmos. A pulsar is both a survivor of violence and a witness to events far beyond itself. It keeps time, not just for its own orbit, but for the universe, whispering across the void with steady light. The magnetism of neutron stars is among the strongest known. Some, called magnetars, possess magnetic fields, trillions of times stronger than Earth's. These fields can twist, crack, and rearrange with sudden fury, releasing bursts of high-energy radiation that sweep across space. A single flare from a magnetar, even thousands of light-years away, can overwhelm detectors on Earth. They are like stars wrapped in storms of invisible force, their fields shaping not only their own surfaces, but the very space around them. To stand on the surface of a neutron star, if it were possible, would be to stand under crushing gravity, where a step would weigh 1,000,000 tons, where mountains could rise no taller than a few millimeters before collapsing under their own weight. Time and space themselves are warped in their presence, gravity bending light, slowing clocks, and stretching space. They are not just objects but distortions, places where the ordinary texture of reality is pulled tight. Neutron stars often live in binary systems, paired with a companion star. In these relationships, they can siphon gas from their neighbor, spinning faster and faster as they are fed. Some rotate so rapidly that they are called millisecond pulsars, turning hundreds of times each second with relentless steadiness. Others tear their companions apart, feeding on them until little remains. These pairings show that even in death, stars do not drift alone. They continue to interact, to influence, to shape the lives of others nearby. When two neutron stars orbit one another closely, their fate is even more dramatic. Over millions of years, their dance brings them closer until they collide in a burst of unimaginable power. These collisions, called kilonovae, release more energy than 1,000,000,000 suns and forge heavy elements like gold and platinum. The jewelry we wear, the metals we value, may have been born in the crash of neutron stars billions of years ago. In their death throes, they not only mark the end of stellar lives but also seed the universe with the building blocks of worlds and civilizations. Neutron stars remind us that the universe is not static but full of transformation. A star that once shone with warmth and light becomes something cold, dense, and strange. A point of collapse turns into a beacon, its pulses sweeping endlessly through space. From destruction comes a new kind of order, a steady ticking where once there was only fire. In their silence, they speak of cycles, of endings that become beginnings, of time itself measured in light and gravity. And so we drift in a universe where, hidden among the billions of stars, are these tiny, dense relics, ticking softly in the dark. They are lighthouses on the cosmic sea, their beams flashing across unimaginable distances, their rhythms carrying the echo of collapse. They are clocks that count, not in hours or years, but in millennia, their precision steady as the universe itself. To imagine them is to imagine stillness and motion fused, gravity and magnetism entwined, silence and signal bound together. A neutron star is what remains when almost everything has been stripped away, leaving only density, rotation, and light. Yet in that simplicity lies elegance. They are reminders that even in collapse, the universe creates patterns of beauty and order. They do not shine with the brilliance of living stars, but with the steadiness of memory. In the end, neutron stars are more than remnants. They are records. They carry in their density the memory of the star that came before. In their spin, the violence of collapse. In their pulses, the rhythm of time itself. They are quiet, hidden, but their ticking continues, steady as the unfolding universe. In their beams, we hear something close to a heartbeat, not of life as we know it, but of the cosmos itself, counting softly in the silence between stars. Time, the quiet rhythm by which we measure our lives, is not as steady as it seems. On Earth, we live by clocks and calendars, trusting that each second is equal to the last, that every hour is the same everywhere. But the universe does not agree. Out among the stars, near massive bodies and in the deep currents of motion, time itself bends and sways. It flows differently depending on where you are and how fast you are moving. The seconds of one life may not match the seconds of another. The universe carries many tempos at once, layered together in ways we can only begin to understand. This truth was first revealed through Einstein's theory of relativity, a vision of space and time woven into a single fabric. According to relativity, gravity is not simply a force pulling objects together, but a curve in this fabric. A planet bends space-time, and clocks close to it tick more slowly than clocks far away. The stronger the gravity, the deeper the curve, and the greater the effect. This is not a trick of perspective. Time itself stretches and slows in the presence of mass. Velocity does the same. As an object moves closer to the speed of light, its clock begins to fall behind those at rest. To the traveler, everything feels normal, but to an observer, their time drags. The faster the journey, the greater the difference, until at the edge of light itself, time would appear to stop entirely. Motion and gravity, two forces that shape our days in ordinary ways, become sculptors of time on the grand stage of the cosmos. Imagine two clocks. One sits quietly on a mountain peak, the other rests in a valley far below. The clock on the mountain, farther from Earth's gravity, ticks ever so slightly faster than the one below. The difference is tiny, invisible in daily life, but measurable with precise instruments. Astronauts orbiting Earth live this difference. Their clocks drift apart from ours, running at a pace we can calculate but cannot feel. The effect is small, but it is real. Time is not absolute. It is personal, local, shaped by the path you walk through the universe. Now picture two twins. One remains on Earth while the other departs on a ship traveling near the speed of light. For the traveler, the voyage may last only a few years, but upon returning home, they would find decades have passed. The sibling left behind has grown old, while the traveler remains young. This is the twin paradox, a thought experiment turned into truth by the laws of relativity. Time is not a single river flowing for all, but many streams, branching and reconnecting, depending on where you stand and how you move. Black holes make this truth dramatic. Near their event horizons, time slows to a crawl. To a distant observer, an object falling in would appear to freeze, its clock halting at the edge. Yet to the falling object itself, time continues normally, rushing forward toward the singularity. Two realities unfold at once, equally true, yet forever separate. The universe allows no reconciliation. In the presence of such gravity, time loses its universality. It becomes fractured, relative, bound to perspective. Even on cosmic scales, this difference shapes our lives. The global positioning system, the satellites orbiting above us, must account for time dilation. Without corrections for both velocity and gravity, our maps and directions would drift, wandering kilometers off course each day. The relativity of time is not only a distant curiosity, but a practical fact of life. Our technology, our navigation, even the phone in your pocket relies on the bending of time being understood and calculated. And yet, the implications remain profound. If time can stretch and slow, then the universe is not experienced the same by all. A star circling near a black hole lives more slowly than one drifting in empty space. A particle hurled to near-light speeds decays more slowly than one at rest. Time is elastic, drawn out or compressed by the invisible hand of relativity. Two beings, two clocks, two lives may diverge in their measure of existence even as they share the same universe. It makes one wonder what now truly means. When you look at a star in the night sky, you are seeing light that left it years, centuries, or millennia ago. You are always gazing into the past, never the present. And the star itself, moving through its own pocket of curved space-time, experiences its moments differently from you. The universe is not synchronized. It is an orchestra without a conductor, each instrument playing its own tempo, weaving a harmony too vast for a single clock to capture. Even as you lie still, breathing slowly, the time you experience is not the same as the time of a drifting satellite above you or a black hole at the galaxy's center. Seconds pass differently, unnoticed but true. The universe is filled with clocks that will never agree, each one bound to its own path. And yet, within this relativity, there is beauty. The elasticity of time allows us to glimpse eternity, to imagine voyages into the future, to recognize that the universe is not rigid, but alive with change. To rest in this thought is to realize how brief and fragile our own time is. A lifetime is but a flicker, a heartbeat in the cosmos, yet within that flicker lies an infinity of difference. Your seconds are yours alone, shaped by your gravity, your motion, your place in the universe. No one else has lived them in quite the same way. Time moves differently in space, and so it moves differently for us all. It is not one thread but many, woven together into a vast tapestry that we glimpse only in part. And while we cannot slow its passing, we can marvel at its nature, at the quiet truth that even the seconds slipping by as you drift towards sleep are unique, shaped by the curve of Earth beneath you, by the pull of the stars above, by the silent, endless motion of the cosmos. When you look up at the night sky, you are not seeing the universe as it is. You are seeing the universe as it was. Every point of light is a message carried across time, traveling through emptiness at a speed no material object can match. Light moves fast enough to cross the planet in an instant, yet the spaces between stars are so wide that even at this greatest speed, it takes years, centuries, even eons to arrive. What shines down on you tonight is history, a tapestry of past events stitched in photons. The stars are not just distant, they are ancient, lanterns whose glow is already old by the time it brushes your eyes. The light of the sun takes about 8 minutes to reach Earth. That means you never see it as it is, only as it was 8 minutes ago. If the sun were to vanish at this moment, you would still see its glow for nearly 10 minutes more before the truth arrived. A simple delay, but one that reveals a deeper truth. All vision is memory. Every glance upward is a glimpse backward. Every starlit night, a mosaic of different eras converging on a single moment. The nearest stars are years away. The faint blue shine of Sirius is already 9 years old. When you look at Proxima Centauri, you see a star, as it was more than 4 years ago. And those brilliant knots in the Milky Way's band are tens of thousands of years behind the present. Their light began its journey before humans invented writing, before the first civilizations built their fires. Above you is a living museum, a record of what once was, still arriving, still unfolding, long after the moments themselves have passed. Some galaxies visible in the night sky are millions of light years away. The Andromeda Galaxy, faint but enormous, stares back at us from more than 2 million years in the past. When that light set out, early humans were just beginning to use tools, the first sparks of thought flickering across our ancestors' minds. To gaze at Andromeda is to gaze into prehistory, to see not only across space, but across the deep corridors of time. Farther still, telescopes reach galaxies billions of light years away. Their light began its journey before Earth even formed, a fossil glow from a universe young and unsettled. Light carries more than sight. It carries memory of the events that birthed it. A supernova's blaze reaches us centuries after the star has died, the explosion long gone, yet its echo still painting the sky. A quasar's glow began when the cosmos was young, its black hole blazing with energy in an age we can only reconstruct. Even the faint afterglow of the Big Bang itself still streams across space, a cosmic background that wraps the universe in a veil of ancient radiation. It is the oldest light we can see, nearly 14 billion years old, a soft whisper from the dawn of time. In this way, the night sky is a time machine. It does not allow us to step backward, but it allows us to look backward, to witness what came before. Every star is a diary written in light, every galaxy a chapter of cosmic history still being read. To study them is to become an archaeologist of photons, uncovering stories buried not in stone but in radiance, still traveling faithfully through the dark. Light itself is fragile yet persistent. A single photon can cross intergalactic space without slowing, without aging, without changing its nature. It can dodge dust clouds, slip between galaxies, and still arrive, billions of years later, as fresh as when it was born. In its endurance, light becomes a bridge, not only between stars and worlds, but between past and present. It is the thread that ties us to events long vanished, the messenger that never stops moving, and yet, what we see is never the whole. Many stars that shine overhead may already be gone. Their lives ended in silence, while their light still streams toward us. When you look up, you may be looking at ghosts, lanterns still burning in vision, though extinguished in reality. The universe plays a gentle trick, allowing us to see beauty that no longer exists, reminding us that what we call now is only one layer of many. This truth grounds us in something humbling. You are never looking at the present sky. You are looking into memory, into echoes, into a layered fabric of past moments still arriving. To live in the universe is to live among shadows of what once was, even as new light begins its journey outward from Earth, carrying our own story into the dark. One day, perhaps, distant eyes will see the glimmer of our sun and our world as they were eons ago, long after we are gone. Light is the universe's most faithful traveler. It never rests, never pauses, never turns back. It is both fleeting and eternal, crossing the abyss with grace, delivering messages no matter how long the road. To sit under the stars is to sit among history books written in brilliance, each one still speaking across the silence of distance. And so tonight, as the stars shimmer above you, remember that they are not merely points of light, but living messages, each one carrying a story older than any human memory. You are surrounded not just by space, but by time stretched into vision, by echoes of a cosmos still unfolding. Every glance upward is a communion with the past. Every star is both present and gone. Every night sky is a reminder that we are readers of light, turning pages written long ago, still glowing in the infinite dark. When we imagine the universe, it is tempting to picture it as a vast box, a grand container in which galaxies float like scattered dust. But the truth is, stranger and far less certain, the universe may not have an edge at all. It may not even have a shape we can fully picture. What we call space is not just a backdrop, but a structure, and that structure can bend, curve, or stretch, depending on the energy and matter it holds. To speak of the universe's shape is to ask not how it looks from the outside, but how it behaves from within, how lines are drawn, how light travels, how journeys unfold when extended to the farthest horizons. Scientists describe three possibilities. The first is a universe that is flat, stretching endlessly in every direction like a boundless sheet. In such a universe, parallel lines never meet. Triangles add up neatly, and light travels in straight paths forever. A flat universe has no end and no curvature. It is infinite and steady, extending without boundary, like a sea with no shore. From our measurements so far, this seems to be the strongest contender, a cosmos without edge, balanced precariously between expansion and gravity. The second possibility is a closed universe, curved like the surface of a sphere. Such a cosmos is finite, but without boundaries, much like the Earth itself. You can travel across its surface without ever finding an edge, circling endlessly yet contained within a hole. In a closed universe, parallel lines eventually converge, light curves back on itself, and the cosmos is like a great bubble, wrapping everything within its rounded embrace. If this is our home, then the farthest journeys may one day return to their starting point, as though the universe were a grand loop of space and time. The third possibility is an open universe, curved like a saddle, spreading out in hyperbolic arcs. In such a structure, lines diverge, distances stretch, and the farther one looks, the more disjointed the geometry becomes. An open universe expands without end, carrying its galaxies ever farther apart, thinning with time, never to return. It is a place where even infinity feels restless, where the very shape of space carries a momentum that pushes things forever outward. These three visions, flat, closed, and open, are not simply poetic metaphors. They are deeply mathematical models, rooted in Einstein's equations of relativity and tested by observations of the cosmic microwave background. The faint afterglow of the Big Bang, spread across the sky, carries tiny fluctuations, ripples of early light that reveal how space itself bends. By studying these patterns, astronomers have concluded that the universe is remarkably close to flat, as though balanced on the edge of possibility, neither collapsing into a sphere nor flaring outward into a saddle. And yet, even with our instruments, the truth is not final. Our data can only reach so far, and the cosmos may hold subtleties beyond what we can see. To imagine a flat universe is to imagine infinity. It is to stand on a cosmic shore and realize there is no horizon, only endless water stretching in all directions. But infinity is not easy to hold in the mind. We are creatures who live by boundaries, days and nights, births and deaths, beginnings and ends. The thought of an unbroken plane of existence, unending in both directions, is unsettling but also strangely calming. In such a universe, there is always more, always another stretch of stars beyond the last, always another cluster glimmering past the edge of sight. A closed universe, on the other hand, carries a certain comfort. It is complete, finite, self-contained. To live in a cosmos that curves back on itself is to live in a grand sphere, a place with no edge but with a wholeness, a certainty of enclosure. The stars may seem infinite, but in truth, they would all be part of one seamless whole, like islands on a curved sea. Travel far enough, and you might one day arrive back where you began, circling through eternity on the currents of curved space. An open universe is more haunting. It suggests that space is not only vast, but restless, shaped like a saddle, forever stretching outward. In this cosmos, expansion never ceases. Galaxies slip away, and the future is an endless dispersal into cold emptiness. There is no returning, no circling back. Everything drifts apart, pulled by the geometry itself. To think of this universe is to think of a sea with currents that never close, a horizon that always recedes, a journey with no possible return. And yet, as different as these visions are, we do not yet know which one is ours. We measure, we test, we map, and still the shape of the universe remains one of the greatest mysteries. It may be flat, infinite, and steady. It may be curved, finite, and whole. It may be hyperbolic, open, and endless. It may even be something we have not yet imagined, a shape beyond the grasp of our minds, too vast, too subtle, too foreign to describe with the words of Earth. This uncertainty is not a failure. It is a reminder that the cosmos is not ours to fully capture. We are like sailors on a boundless sea, charting stars and currents but never seeing the whole ocean at once. The maps we draw are partial, sketches of a reality that stretches beyond sight. Perhaps the true shape of the universe is not meant to be fully known, but only glimpsed, like the curve of a sail in the wind, hinting at a vastness we cannot see in total. So tonight, as you think of the universe's form, remember that you are already within it. You are part of its curvature, its geometry, its quiet unfolding. Whether the cosmos is flat or round or open, you are a thread in its fabric, moving with it, carried along by its expansion, bound by its hidden shape. You do not need to know its edges to belong to it. You already do. The shape of the universe is still a question, but in that question lies wonder. It is a mystery vast enough to hold us, gentle enough to invite us, and enduring enough to remind us that the journey through space is also a journey through possibility. We do not yet know, and perhaps we never will. But the not knowing is part of the beauty. For to live in mystery is to live awake, adrift on the cosmic sea, beneath sails we cannot see, but that carry us all the same. If you close your eyes and imagine the beginning of everything, you might picture fire, heat, a burst of brilliance that flooded the void with light. But the truth is quieter now, softened by time. The afterglow of that beginning still lingers, faint and cool, stretched thin across the heavens. It is called the cosmic microwave background, and though it hums invisibly beyond the reach of your eyes, it fills all of space, bathing every corner of the universe in a glow older than stars, older than galaxies, older than even the first atoms that gathered into form. It is the universe's oldest memory, the ember of a fire that burned long ago but never fully went out. More than 13 billion years have passed since the universe erupted from its hot and dense beginning. In those first fractions of a second, expansion was wild and rapid, a storm of energy flaring outward, a moment we call inflation. In that era, temperatures were so intense that matter and radiation were one, inseparable, like light bound in a storm of particles. The universe was opaque then, a swirling fog where photons scattered constantly, never able to travel freely. To be alive in that time would have been to see nothing but brightness with no form, heat without horizon. But as expansion carried on, the fire cooled. Matter began to separate from radiation. Atoms of hydrogen and helium formed, and the fog lifted. For the first time, light was set free to travel unimpeded through space. That first light is the glow we still detect today, stretched and thinned by the universe's expansion into the faint microwave background that surrounds us. It does not look like fire anymore. It does not blaze. Its temperature is just a whisper above absolute zero, about 2.7 Kelvin. But in that faintness lies its age. What was once a searing white light has been stretched into invisible microwaves, cooled by time and distance. To astronomers who study it, the cosmic microwave background is not a picture of today's universe, but a fossil, a preserved snapshot of the cosmos, as it was when it was only about 380 years old. Compared to the universe's present age of 13.8 billion years, that is infancy. When you look into this glow, you are looking into the cradle of everything. It is astonishing to think that such an ancient signal still reaches us. Every second, trillions of photons from the cosmic microwave background pass through you, through the walls around you, through the earth itself. They are everywhere, flowing invisibly and silently. They are reminders that the past never truly vanishes, but echoes onward, stretched across space in threads of light. We are bathed in history without even noticing it, surrounded by a chorus too faint for our senses but persistent all the same. The discovery of this background radiation was an accident. In 1965, two engineers, Arno Penzias and Robert Wilson, were testing a radio antenna in New Jersey when they encountered a persistent noise. It came from every direction, day and night, and no matter how they cleaned the equipment or chased away pigeons nesting in the antenna, the noise would not go away. They had stumbled upon the universe's afterglow, a faint static left behind from the Big Bang itself. What seemed like a nuisance turned out to be the oldest message ever received, proof that the universe had once been hot, dense, and radiant. Since then, we have mapped this glow with greater precision. Satellites like COBE, WMAP, and Planck have revealed that the microwave background is not perfectly smooth. It contains tiny ripples, minute fluctuations in temperature just a few millionths of a degree. These ripples may seem small, but they are profound. They are the seeds of structure, the fingerprints of the early universe. Over billions of years, gravity magnified these slight differences, pulling matter into clumps, forming galaxies, stars, planets, and eventually us. In the faint blotches of the microwave background, we see the first outlines of the universe's destiny written when it was still a child. Think of it like the ember of a long-cooled fire. The flame is gone, the heat has faded, but a faint warmth remains, glowing in the ashes. That warmth tells you that something once burned fiercely. In the same way, the cosmic microwave background is not the fire itself, but its echo, the soft radiance that reveals a time when the universe blazed with unimaginable energy. It is the universe remembering itself, carrying within its light the story of beginnings. The poetry of this is not in its numbers, but in its persistence. Light that began its journey nearly 14 billion years ago has not gone out. It has traveled through every age of cosmic history, past colliding galaxies, through the slow drift of stars, past the births and deaths of countless suns, all to arrive here, now, brushing softly against you as you rest. It is as though the universe has been whispering for all eternity, and only recently have we learned to listen. We call it background, but it is more like a foundation. Without it, we would not know our origins with such clarity. Without it, the Big Bang might remain only a theory, a story without proof. But this glow is undeniable. It tells us that the universe had a beginning, that it expanded, that it cooled, and that it carried within itself the seeds of all we now see. In its faintness lies certainty. In its silence lies a map of everything that would follow. And yet, as we listen to it, we also hear its mystery. Why did the universe expand the way it did? Why do the ripples fall into the precise patterns we observe? Why is the cosmos so close to flat, balanced on the edge of geometry? The microwave background does not answer all these questions, but it frames them. It sets the stage for our curiosity, for the next chapters of discovery. Tonight, as you drift, remember that you are not in darkness. You are wrapped in ancient light, older than Earth, older than the sun, older than galaxies. It is faint, invisible to your eyes, but it is there, passing through you like a quiet river. The cosmic microwave background is not just radiation. It is memory, persistence, and continuity. It is the universe's first breath, still echoing, still touching everything it made. The oldest light is still whispering. When you look up at the night sky, it can seem as though stars are all there is. Countless points of light, some brighter than others, some clustered together in hazy patches, some scattered and solitary. For most of history, people thought stars were fixed and eternal, each shining alone in the dark. But we now know that many of those stars are not alone at all. They are accompanied by worlds, billions upon billions of them, circling in silence, hidden by distance. These are the exoplanets, planets beyond our solar system, and their sheer abundance has transformed how we see the universe. What was once an empty stage has revealed itself to be crowded with unseen companions, each one holding its own secrets. The first confirmed discovery came only in the 1990s, a blink ago in the timeline of science. A handful of planets were detected indirectly, their presence betrayed by the wobble of their stars or the faint dimming of starlight as they passed across the stellar face. At the time, they seemed unusual, even exotic. Hot Jupiters, gas giants orbiting closer to their stars than Mercury does to the Sun, defied everything we expected. They told us immediately that planetary systems can look very different from our own. Since then, the list has grown into the thousands, with new candidates appearing almost daily. By now it is clear, planets are not rare exceptions. They are the rule. In the Milky Way alone, there may be more planets than stars. Imagine that. Over 100 billion stars, and most with their own families of worlds. Some systems may have just one or two companions. Others may host entire crowds of planets, small rocky bodies huddled close, and giant spheres drifting far out, all turning together in slow, silent harmony. Some may orbit suns brighter than ours. Some cling tightly to red dwarfs that glow dimly in crimson light. And some wander without a star at all, rogue planets drifting through the galaxy in darkness, carried only by momentum, exiles of cosmic history. The variety is staggering. There are super-Earths, rocky worlds larger than our planet, where gravity would press more heavily on every step. There are gas giants so swollen that their atmospheres brush dangerously close to their stars, heated into glowing halos. There are planets made of ice, frozen far from warmth, their surfaces locked in perpetual night. Some may have oceans deeper than anything on Earth, entire mantles of liquid water shrouded by crushing pressure. Others may be deserts, scorched and cracked under merciless suns. The spectrum of worlds is wide, far beyond what we once imagined, when we looked only at the 8 planets of our own system. Among them, scientists search for those rare places that might harbor life. Not too close to the star, where heat would boil oceans away. Not too far, where cold would seal everything in ice. These are the habitable zones, sometimes called Goldilocks zones. Worlds balanced in the narrow band where liquid water could flow. On Earth, water has proven to be the cradle of life, and so we seek it elsewhere. We imagine distant blue planets with clouds drifting over seas, continents stretching into unknown shapes, alien skies arching over alien landscapes. Most may be barren, but even the possibility of one living world among billions is enough to stir wonder. It is humbling to realize how young this search still is. We cannot yet see the surfaces of these worlds. We cannot yet stand on them or breathe their air. But we can measure their shadows, their motions, and sometimes even the thin fingerprints of their atmospheres when starlight passes through. With these delicate clues, astronomers can tell whether a planet's sky holds water vapor, methane, or oxygen. We are learning to read the invisible, to listen for signs of habitability across light years. In time, our instruments may grow sharp enough to glimpse continents, to map weather, perhaps even to recognize the chemical marks of life itself. Think of what that means. Right now, as you rest beneath your ceiling or beneath the open sky, light from distant stars is carrying the story of other worlds toward us. Some of that light has been traveling for hundreds or thousands of years, and in its journey it has crossed entire planetary systems, grazing the atmospheres of unseen places. Within that starlight is information we are only just beginning to decode. Every faint dimming, every spectral line is a message from a world we cannot see but know must be there. Somewhere, perhaps, another eye looks back. It may not belong to a being like us. It may not belong to a being at all, but to a creature that perceives in ways we cannot imagine, living beneath seas of methane or skies tinted green by chemical suns. Or perhaps it belongs to nothing conscious at all, just a quiet landscape of rock and air and water, waiting silently as the universe moves on. The possibility itself is enough. In a cosmos so vast, it feels almost arrogant to believe that Earth is singular in its gift of life. Yet, even if no other living world is ever found, the knowledge of these planets changes us. It expands the stage. The night sky is no longer only stars. It is filled with hidden landscapes, scattered across light years, each one a reminder that we are not the only chapter the cosmos is writing. Every world, lifeless or not, carries part of the universe's story, sculpted by gravity, carved by time, shaped by the same laws that shaped us. So when you look up, remember that you are not only seeing stars, you are glimpsing entire systems of unseen worlds, some burning close to their suns, some drifting in lonely exile, some perhaps carrying oceans and skies. The galaxy is crowded with planets, far more than we will ever visit, far more than we can even count. But the knowledge that they are there makes the universe feel both larger and more intimate. We are surrounded by other homes, scattered like lanterns across the dark, and though most will remain beyond our reach, their existence reminds us of something essential. We are part of a universe that creates endlessly, not just stars, but worlds. Not just light, but the possibility of life. And in that endless creation lies both mystery and comfort, a quiet truth that hums beneath the silence of the night. The universe, for all its quiet stretches and patient rhythms, is not always calm. It carries within it the seeds of upheaval, events so vast and powerful that they would outshine entire galaxies, bend the shape of space, or leave scars written in light. We call them catastrophes, but that is a word born of human scale, a word too small to describe what truly happens. In the cosmos, these are not accidents or disasters. They are part of the pattern, part of the endless cycles of creation and transformation. What may seem violent to us is only change, playing out on a stage too wide for fear. They are storms in a sky too wide to grasp. Consider a gamma-ray burst, among the most energetic events we know. For a brief moment, lasting only seconds or minutes, they can release more energy than the sun will produce in its entire lifetime. Astronomers believe these outbursts come from the collapse of massive stars or the collision of neutron stars, their matter compressed and spun into jets of light so powerful they pierce across billions of light years. If your eyes could see gamma rays, you would witness brilliant flashes flickering across the sky, sudden lighthouses in the dark, each marking a cataclysm beyond imagination. Yet as terrifying as they might sound, they are far away. Their light reaches us only as a whisper of what once happened, carrying no harm, only knowledge. Colliding galaxies are another form of cosmic upheaval, but one that moves at a pace slower than thought. When galaxies drift toward each other, their stars do not crash headlong in fiery destruction. Instead, gravity weaves them together, pulling arms into arcs, stretching clusters into long streams, reshaping the great spirals into bridges of light. The Milky Way itself is on such a path with the Andromeda Galaxy, and in billions of years, the two will merge into one. To us, it is unimaginable, but to the universe, it is as natural as clouds passing in the wind. Stars will continue to orbit. New ones will be born. The shape will change, but the essence remains. A collision of galaxies is not an end, but a transformation, a new pattern written in the dark. Supernovae, too, belong to this tapestry. When a star many times larger than our sun reaches the end of its life, it cannot fade quietly. Its core collapses in an instant, and the outer layers are hurled into space with such force that the explosion can outshine a galaxy. The light can be seen across millions of light years, blazing briefly before dimming into memory. But within that blaze lies renewal. Heavy elements like iron, gold, and uranium are forged in the explosion and scattered into space. They seed the next generation of stars, the next planets, the building blocks of life. Without supernovae, there would be no Earth, no oceans, no people to wonder at the sky. What looks like destruction is, in truth, the beginning of everything we know. These events are dramatic not because they threaten us, but because they remind us of scale. The universe is not fragile. It is vast enough to endure explosions brighter than galaxies, collisions spanning millions of years, storms of radiation that flicker and fade without touching us. They unfold far away, at distances so great that their light takes longer than human civilization to arrive. To us, they come only as messages, echoes of a living cosmos that is constantly reshaping itself. We are the safe observers, listening to distant thunder without ever feeling the storm. It helps to think of them not as catastrophes, but as cosmic weather. Stars explode like lightning strikes. Galaxies merge like tides colliding. Gamma-ray bursts flicker like sudden sparks on a windy night. All are transient, powerful, and part of a greater balance. The calm of the night sky exists alongside its turbulence. The same universe that offers quiet starlight also holds within it events of unimaginable scale, and yet both belong to the same whole. Both are necessary. Both are beautiful. When we speak of cosmic catastrophes, we are really speaking of change, of cycles turning endlessly. Nothing is permanent. Stars burn and fade. Galaxies stretch and transform. Light blazes and then dims. Even space itself expands, carrying everything farther apart. These events may seem destructive, but in their wake comes new creation. Supernovae enrich space with metals. Galaxy collisions trigger waves of star formation. Neutron-star mergers scatter gold and platinum across the cosmos. The universe does not waste. It recycles endlessly, turning endings into beginnings. To rest beneath the sky and think of these things is not to feel fear, but to feel perspective. The storms of the universe are not aimed at us. They are part of a story much older and larger than anything on Earth. We live in a quiet corner, shielded by distance, where the great fires of creation play out only in the light that drifts gently to us after unimaginable journeys. The night sky is calm because we are far away, but hidden within that calm are histories of explosions, collisions, and transformations that gave us everything we are. Somewhere right now, a star is collapsing, becoming a black hole or a neutron star. Somewhere else, two galaxies are beginning their long embrace. And in a distant corner of the cosmos, a gamma-ray burst has just flared, its light now on a path that may one day touch our skies. These things happen constantly, not in the sense of a single moment, but in the flow of cosmic time. And while they may seem rare to us, in the great expanse of the universe they are common, natural, as rain. The universe is not gentle in the way a quiet night might suggest. It is alive with storms, fire, and motion. But it is also steady, balanced, and endlessly renewing. To witness its scale, even from afar, is to be reminded that our small lives are sheltered within something vast. We are not at risk from these events. We are their legacy. Our atoms were forged in explosions, scattered by supernovae, gathered in clouds shaped by collisions, warmed by the quiet light of stars that endured past chaos. We are the outcome of cosmic catastrophe, the calm that followed, the life that rose from dust. And so, when you think of the universe's most violent moments, do not think of fear. Think of transformation. Think of the sky not only as a place of peace, but as a place where storms rage in silence, reshaping the stars, weaving new galaxies, and scattering the ingredients of life across the dark. You are not apart from this. You are a continuation of it. Every breath, every heartbeat, every thought is made possible by the quiet aftermath of distant cataclysms. What seems destructive at first glance is, on the scale of the cosmos, nothing less than creation. The night sky appears still, a dark canvas scattered with stars, yet silence does not mean emptiness. All around you, even in this quiet moment, invisible forces move ceaselessly, weaving through the air, through the ground, and even through your body. They leave no trace that you can sense, no sound, no light, no warmth. Yet they are there, endless and persistent, shaping the universe as surely as the gravity that holds you to the earth. To rest beneath the sky is to rest within a storm of hidden motion, a sea of unseen currents, flowing everywhere, always. One of these hidden presences is the galaxy's magnetic field. It does not shine. It does not ripple like water, yet it stretches across hundreds of thousands of light years, threading through the disk of stars, arching into the halo, and looping back again. Weak by the measure of earthly magnets, but immense in reach, it shapes the way particles move, how gas collapses, how energy flows. Dust grains align along its lines like iron filings on a page, polarizing the starlight we see. Cosmic rays bend through its currents, redirected like leaves caught in a wind. If you could see the galaxy's magnetism, the night sky would glow with invisible spirals, arcs of energy curving gracefully beyond vision. You are never outside it. Every moment of your life has been lived inside a field you cannot touch, a quiet architecture of the cosmos. Even smaller, even stranger, are the particles called neutrinos. They are ghosts of matter, born in the nuclear hearts of stars, in the blast waves of supernova, in the collisions of galaxies and black holes. Trillions of them pass through your body every second, streaming through your skin, your bones, the earth itself, almost never stopping. They do not slow, they do not scatter. They move, as if the universe were transparent, slipping past atoms without pause. And yet in rare moments, in detectors buried beneath mountains or frozen into the Antarctic ice, they collide, releasing faint sparks of light that tell their story. When you breathe, when you dream, when you simply lie still, you are crossed by countless neutrinos carrying messages from the cores of stars millions of light years away. You are never alone in the dark. Cosmic rays too move through you, though they arrive less gently. They are fragments of atoms, hurled into space by violent events, supernova, collapsing stars, colliding galaxies. They travel at near the speed of light, slamming into Earth's atmosphere, striking molecules and creating showers of secondary particles that cascade downward like invisible rain. Some of those fragments reach you, passing through without harm but leaving behind the memory of their impossible journey. Each one may have begun far away, in a star that lived and died before Earth was born. To think of this is to realize that the universe is not something distant, but something that flows through you constantly, in silence, unseen. Magnetic fields, neutrinos, cosmic rays, each is part of the unseen framework of reality. They shape galaxies, they carry messages, they bind together what otherwise might drift apart. You cannot sense them directly, but your body is already touched by them. In a very real sense, you are not just living in the universe. You are immersed in it, crossed by it, interwoven with its quiet energies. Even the calmest moment of rest is alive with activity. Imagine lying still, your breathing slow, your thoughts drifting. Around you, space is filled with starlight, but also with signals you cannot see. Particles older than Earth slip through your chest and out again, undisturbed. Fields from the galaxy sweep across you, bending waves of radiation, guiding the dance of dust and gas across unimaginable distances. Rays born in explosions long ago race through the atmosphere above you, fragments of forgotten stars showering invisibly over the quiet Earth. You are not apart from this storm. You are within it, as much a part of its motion as any atom, any star. There is something humbling in this. We tend to think of ourselves as grounded, solid, existing in a world of touch and sight. But the truth is that our bodies are transparent to much of the universe, open to rivers of particles and currents of fields that pass without resistance. We are not closed systems. We are porous, fleeting, touched by things that never stay. You may not feel them, but they are there, shaping even the matter that makes you, carrying traces of events that happened before humanity began, before Earth began, before the galaxy took shape. If you could slow time and sharpen your senses, perhaps you would feel it, the tick of neutrinos, like raindrops on glass, the hum of magnetic fields as threads of invisible silk, the crackle of cosmic rays as faint sparks brushing your skin. Perhaps you would realize that the silence you hear is filled with a symphony too fast, too faint, too hidden to perceive. And yet it is real, constant, endless. The quiet of the night is only quiet to human ears. To the universe, it is alive with motion. As you rest, the invisible forces continue their work. Neutrinos pour outward from the heart of the sun, bathing the solar system in ghostly light. Magnetic fields bend and shape, holding together clouds of gas that may one day form new stars. Cosmic rays streak endlessly across space, carrying with them the memory of ancient explosions. You do nothing, and yet you are part of this flow. Every heartbeat, every breath, every moment of stillness is wrapped in it. You are not separate from the universe's hidden forces. You are surrounded by them, carried by them, written into them. The visible sky, bright with stars and galaxies, is only one layer of reality. Beneath it lies another, woven of invisible forces and silent streams. It does not dazzle the eyes, but it is no less profound. To know that you are touched by particles from distant stars, that you are living inside a web of fields spanning the galaxy, that you are crossed each second by the faint whispers of the cosmos. This is not frightening. It is grounding. It is a reminder that even in the stillness of the night, you are never apart from the whole. And so, as you drift toward rest, imagine yourself not only lying beneath the stars, but drifting in their hidden currents. Picture neutrinos like silent rivers flowing through your body, magnetic fields like threads of silk weaving around you, cosmic rays like sparks of light too faint to see. Let the thought calm you. You are part of a universe that does not need to be seen to be felt, a universe alive with invisible motion. You are carried in its quiet hands, and the silence you hear is full of endless music. The universe has a beginning, but what it does not yet have is an ending we can be certain of. Scientists look into the deep past, studying faint light and gravity's subtle fingerprints, and from those clues they try to imagine where all of this is heading. There are several possibilities, and each carries its own poetry. None of them will arrive in the span of human lives, or even in the lifetimes of stars. They belong to a future so far away that it almost feels like myth. And yet, like the gentle knowledge that night follows day, they remind us that even the cosmos itself has a story with chapters still unwritten. One possible ending is the Big Freeze. The universe has been expanding since the Big Bang, galaxies drifting apart as space itself stretches. Over billions upon billions of years, this expansion will continue, faster and faster. Stars will burn out one by one, their fuel spent. The bright spirals of galaxies will dim into collections of dark remnants, white dwarfs cooling into black husks, neutron stars fading into silence, black holes swallowing what little remains. The sky will grow darker, until only the faintest embers flicker in an endless night. Planets, if any remain, will circle cold stars, frozen and lifeless. Imagine the warmth of every candle in the universe slowly burning out, until only smoke remains. That is the vision of the Big Freeze, a cosmos not destroyed, but drained of its fire, drifting into a quiet so deep it may last forever. Another vision is more violent, the Big Rip. In this scenario, the mysterious force known as dark energy continues to push the universe apart, but not at a steady pace. Instead, it accelerates endlessly, pulling harder with every passing age. Galaxies would be torn away from one another, then stars ripped from galaxies, then planets from their stars. Even atoms would not remain safe. In the final instant, the very fabric of matter could unravel, as if the universe itself were a tapestry pulled thread by thread, until nothing is left but loose strands. If the Big Freeze is like a candle slowly dying, the Big Rip is like the candle shattering in an instant of final violence, a sudden ending, but one far beyond the reach of time we can imagine. There is also the thought of the Big Crunch, a kind of mirror to the beginning. If gravity one day overcomes expansion, then all the galaxies will stop drifting apart and begin to fall back together. The universe would reverse its breath, inhaling instead of exhaling, pulling stars, planets, and every atom back toward a single point. The night sky would grow brighter as galaxies drew closer, until everything collapsed into a final fireball, perhaps leading to another birth, another beginning. In this vision, the universe is not a line, but a cycle, expanding and collapsing again and again in a rhythm of creation and destruction. The Big Crunch is not an ending so much as a turning of the page, the folding of one sky to make room for another. And still, other possibilities linger. Some scientists imagine a far stranger end. In one, the vacuum of space itself may not be stable. It could collapse into a lower energy state, creating a bubble that expands at the speed of light, erasing everything in its path in an instant. It sounds terrifying, but it is not a fear for us, for our world, or even for our galaxy. If it ever happens, it will unfold on scales of time and distance so vast they exceed imagination. For now, it remains only a whisper of theory, a quiet reminder that the universe is still full of mysteries not yet solved. No matter which ending comes, it is not near. These are not events measured in centuries or even in the age of stars, but in spans of time that dwarf the lifetime of the universe so far. The Big Freeze would take trillions of years, a time so long that even words like forever feel too small. The Big Rip, if it ever occurs, would arrive only after galaxies have lived out their ages in silence. The Big Crunch, if it waits, will not begin until the universe is far older than it is now. Every version of the end lies further ahead than we can measure, further ahead than Earth itself is likely to endure. This distance of time can bring peace. Just as you do not worry about the stars ceasing to shine tonight, you need not carry the weight of the universe's fate. These endings are not warnings, but meditations. They remind us that the universe is alive in its own way, a great system in motion, subject to laws that carry it forward. Its death, if it comes, is only another part of its life. To think of it now is to listen to the ticking of a clock so vast you will never hear it strike. Imagine, if you will, the sky dimming one candle at a time, galaxies fading like lanterns carried farther and farther across an endless sea. Or imagine the opposite, the sea folding back, waves collapsing into a single point, light gathering to return where it began. Or else the threads of existence unraveling in an instant, a final dissolution. Each vision is both an ending and a transformation, a reminder that nothing, not even the universe, is untouched by change. For now, though, the stars still burn, galaxies still whirl in their spirals, light still crosses the dark, and you still breathe beneath it. The fate of the universe belongs to a future no one will see, but the present belongs to you. And in this present, the cosmos is alive, vibrant, radiant, still unfolding its wonders. To rest beneath the sky tonight is to rest within a universe still in motion, still burning, still alive. The ending may wait, but for now, there is only the story, vast and unfinished, written in stars that still shine. The universe does not keep diaries, nor does it carve monuments in stone, yet it remembers. Its memory is not written in words, but in light, in elements, in the quiet persistence of patterns that endure across billions of years. Every star, every galaxy, every atom carries with it the record of what came before. To look out into the cosmos is to read history inscribed not on paper, but on the very fabric of matter and energy itself. The universe remembers in ways we are only beginning to understand, and each time we learn to read one of its languages, another chapter of its story opens before us. The chemistry of stars is one such language. A star's light is more than brilliance. It is a spectrum, a rainbow fringed with subtle dark lines that mark the fingerprints of the elements within it. Hydrogen, helium, carbon, iron, all leave their traces in the glow of a star. By studying those traces, astronomers can tell not only what a star is made of, but when it was born, how many generations of stars came before it, and what cosmic events shaped its birth. A star with only hydrogen and helium is an ancient one, formed in the early universe when heavier elements had not yet been created. A star rich in metals and complex atoms is younger, born after countless supernovae seeded the galaxy with the dust of prior lives. Each star is both itself and a record of everything that led to its creation. Galaxies, too, hold memory. Their shapes, their clusters, their streams of stars, all testify to long-forgotten collisions and mergers. A spiral galaxy's graceful arms are evidence of past interactions, waves of density rippling outward from encounters with companions. Faint streams of stars stretching from the edges of galaxies are the fossils of smaller systems torn apart by gravity, their remnants still tracing the path of destruction. The Milky Way itself bears scars of such events, carrying the ghosts of dwarf galaxies that fell into it long ago. When we map its structure, we are mapping not just where stars are, but where they came from, how they moved, what dances of gravity shaped them across eons. Even the oldest stars remember. Globular clusters, tight balls of ancient suns orbiting in the halos of galaxies, are among the oldest structures in the universe. Some are nearly as old as the cosmos itself, their stars still shining with the faint light of an era when galaxies were only beginning to form. These clusters are fossils of the early universe, preserved relics from a time before the familiar shapes of spirals and disks had yet emerged. To gaze at one is to gaze directly into the deep past, into a piece of the cosmos that has remained unchanged for more than 10 billion years. They are the memory of youth, still glowing softly in the vastness of the present. The elements in your body carry memory as well. The oxygen you breathe was forged in stars that lived billions of years ago. The calcium in your bones, the iron in your blood, the carbon in every cell, all of it was once part of a star that burned, exploded, and scattered its ashes into space. Those atoms are not only ancient, they are storytellers. They tell of the cycles of stellar death and rebirth, of matter endlessly recycled, of a universe that remembers by creating and recreating itself. When you breathe, when you move, when you simply exist, you are carrying the record of supernovae within you. You are the memory of the universe made flesh. Light itself carries remembrance. When you look at a star, you see it not as it is, but as it was. Its light may have traveled for years, centuries, even millennia to reach your eyes. The glow you see tonight could be the last message of a star already gone, its memory carried across space by photons that refuse to fade. Galaxies billions of light years away shine to us now as they were in their youth, their light stretched and softened by the expansion of space. When astronomers study that faint glow, they are studying the history of the universe itself. The night sky is not only beauty, it is memory made visible. Even emptiness remembers. The cosmic microwave background, that faint afterglow from the Big Bang, is a record of the universe when it was only 380 years old, a time when no stars or galaxies had yet formed. It is the oldest memory we can observe directly, a whisper of light from the first breath of the cosmos. In its subtle variations lie the seeds of all structure, the faint echoes of fluctuations that grew into galaxies, clusters, and filaments stretching across billions of light years. The universe carries its beginnings with it, written in the radiation that still surrounds us today. To reflect on this is to realize that nothing is ever entirely forgotten. Stars may explode, galaxies may collide, particles may drift into silence, but their effects endure. Gravity preserves motion. Light preserves moments. Atoms preserve the legacy of ancient fires. Even silence preserves, for in the gaps between galaxies lies the record of expansion itself, the stretching of space, a memory written into the structure of the cosmos. The universe does not erase, it transforms. Its history is not lost, but folded into every layer of its being. There is a kind of comfort in knowing this. Human lives are brief, and memory is fragile. We forget more than we keep, and even our greatest monuments are small compared to cosmic time. But the universe itself remembers. It remembers in stars that shine with the chemistry of past generations. It remembers in clusters that preserve the echoes of youth. It remembers in the atoms that make up your body, each one a relic of ancient creation. In a way, you are part of that memory. You are one of the ways the cosmos holds on to itself, a flicker of awareness in a universe that never truly forgets. So when you look at the night sky, think of it not only as present light, but as history unfolding before you. Each star is a line in a diary billions of years old. Each galaxy is a chapter written in collisions and tides. Each atom in your breath is a word passed down from a fire that burned long before Earth existed. You are surrounded by memory. You are built from it. And as you move through your own brief span of time, you are adding to it, a quiet trace that will ripple outward long after you are gone. The universe remembers. It always has. And in that memory, everything, every star, every world, every breath remains part of the story forever. Begin with the smallest thing you can feel. The ground beneath your feet, the air in your lungs, the faint rhythm of your heartbeat. These are the boundaries of your everyday world, the things most immediate and certain. Yet each of them belongs to a chain that stretches outward, step by step, until it includes the whole of the universe. To know your place is not to feel diminished, but to see that you are both small and infinite at once, folded into a cosmic address that begins with Earth and extends to the farthest galaxies. Our planet orbits an ordinary star, one among hundreds of billions in the Milky Way. The sun is not the brightest, nor the largest, nor the most unusual. It is steady, reliable, burning hydrogen into helium with a patience that will last for billions more years. Around it circle 8 planets, countless moons, comets, and asteroids, all bound by gravity into a fragile family of worlds. Earth is one of them, tilted just so, warmed at the right distance, wrapped in an atmosphere that allows rivers, oceans, and life to flourish. Already, in this first step outward, you see that our home is both ordinary and miraculous, just one rock among many, yet the only one we know that has learned to dream. Beyond our sun lies the Milky Way, a galaxy shaped like a spiral, its arms curling gracefully outward in streams of stars. We live on a minor arm called Orion's Spur, far from the galactic center, tucked away in a quieter neighborhood. If you could rise above the galaxy and see it in its entirety, you would find the sun and Earth invisible, lost among billions of other points of light. But within the galaxy's vastness, our star shines just the same, carrying its family of worlds through the spiral arms in a slow orbit that takes more than 200 million years to complete. Every creature that has ever lived on Earth has done so within one tiny segment of that long journey. The galaxy holds us, though we hardly notice the movement. The Milky Way itself is not alone. It belongs to a small cluster of galaxies called the Local Group, about 50 or so bound together by gravity, including our neighbor Andromeda and several smaller companions. These galaxies drift slowly toward one another, connected not by proximity alone, but by the invisible pull that binds them. In billions of years, the Milky Way and Andromeda will merge into a single, larger galaxy, their stars intermingling in a slow, graceful collision. On scales like these, galaxies are not solitary. They live in families, groups, and clusters, each one a node in a larger web. And beyond even that lies the observable universe, stretching for billions of light years in every direction. Galaxies are not scattered randomly, but strung together in filaments, cosmic threads that weave into a vast structure like a web of glowing lace. Between these threads lie immense voids, regions so empty they seem almost like silence itself. To chart this structure is to glimpse the architecture of everything, a map that shows not edges or boundaries, but an endless repetition of pattern. Stars into galaxies, galaxies into clusters, clusters into filaments, filaments into the whole. This is the largest address we know, and even it may not be the limit. Beyond what we can see may lie more, stretching endlessly or circling back upon itself. The universe does not reveal all its secrets at once. When you place yourself in this cosmic address, you may feel the weight of smallness. Earth, one planet among billions of planets circling billions of stars, tucked away in one galaxy among trillions. The numbers exceed comprehension. Against such vastness, what can one life matter? But to dwell only on smallness is to miss the other half of the truth. You are not separate from this whole. You are part of it, written into its structure as surely as any star or galaxy. The iron flowing in your blood was forged in ancient stars. The oxygen you breathe was born when the first plants learned to harness light. The calcium in your bones was shaped from atoms cast out by supernova. Every breath you take is a link in the chain of cosmic memory, a reminder that you are made of the very same matter that fills the universe. Think of it. The stars are not only above you, but within you. Their fire lives in the atoms of your body. Their history is your history. You are not a spectator of the cosmos, but its continuation. The elements scattered in explosions billions of years ago gathered into clouds. Those clouds collapsed into worlds, and on one of those worlds life emerged, grew, and eventually wondered about its origins. To ask about your place is itself a product of the universe remembering itself, consciousness flowering from stardust. In this way, the vastness is not a negation of meaning, but an expansion of it. You belong not only to your street or your town or your planet, but to a structure that encompasses galaxies and timescales beyond imagination. Your life may be brief, but it is connected to eternity. Your body may be small, but it is woven from infinities. To know your place is to feel at once humbled and uplifted, grounded by the soil of earth and expanded by the fire of stars. The night sky, then, is not just a distant spectacle. It is a mirror. Each point of light reflects something of your own composition, your own origin, your own belonging. To trace your cosmic address is not to wander away from yourself, but to return more fully to it, to see that you are at home in every level of this structure, from the cell to the galaxy. The universe does not exclude you. It carries you. And so, when you feel small, remember this. You are small, yes, but not insignificant. You are connected to the whole, written into its chemistry, its gravity, its light. You walk the earth, but the earth itself is part of the solar system part of the galaxy part of the local group part of the vast web of the cosmos. You are not outside of this hierarchy. You are its expression. You are its continuation. To know this is to rest differently beneath the stars. You are no longer only looking up. You are looking in. You are remembering what the universe has already written in your blood, your breath, your bones. You are part of the whole, and the whole is part of you. The journey has taken you far, yet here you are, back where you began, resting beneath a sky that feels both familiar and new. Along the way, you have wandered through stars and galaxies, through birth and death, through beginnings and endings that stretch beyond human time. You have looked at the universe's past and peered into its possible futures. You have traced the invisible and the vast, the violent and the gentle. And through it all, you have carried with you the simple truth that this is not only a story of distant things, but a story that holds you within it. You have seen that the universe has no center, that expansion carries every point away from every other, as though space itself were dough rising in a great oven. You have learned that what is visible is only a fraction of what exists, that most of reality is made of matter and energy unseen, scaffolding and currents that shape everything without revealing themselves. You have heard the age of the cosmos measured not in centuries or even millennia, but in billions of years, time stretched across a calendar in which all of human history is only the last breath of the final day. You have gazed at galaxies as islands of light, so numerous that even a lifetime of counting would barely begin, each one a home for stars uncountable. You have rested in the rhythm of stars themselves, born in clouds of dust, burning steadily across eons, then collapsing into giants, dwarfs, or explosions that scatter their riches into the void. You have drifted near black holes, those silent doorways where gravity traps even light, and you have turned toward neutron stars and pulsars, whose dense hearts tick out time more precisely than any human clock. You have stepped into the paradox of time, learning that it flows differently depending on where you stand, bending to the pull of gravity and the speed of motion. And you have discovered that light is the universe's messenger, carrying across billions of years the memory of what once was, so that to look at the stars is always to look into the past. You have wondered at the shape of the universe, whether it stretches flat into infinity, curves like a sphere with no edge, or bends outward like a saddle. You have listened to the faint whisper of the cosmic microwave background, the afterglow of the first fire still humming all around you. You have imagined other worlds, billions of them, scattered across the galaxy, some hot, some frozen, some drifting alone in the dark, and some balanced in just the right light where water might flow. You have seen the grandeur of cosmic catastrophes, gamma-ray bursts, and colliding galaxies, supernovae scattering gold and oxygen, and you have recognized them not as threats, but as natural cycles, storms that bring new creation. You have allowed yourself to feel the touch of invisible forces, magnetic fields, neutrinos, cosmic rays moving through you constantly, reminders that the universe is not only above but also within you. You have considered the fate of everything, whether the stars will one day fade into a great freeze, or the cosmos will tear itself apart in a rip, or fold back into itself in a final crunch. You have learned that the universe remembers, writing its story in starlight, in the chemistry of ancient suns, in the atoms of your own blood and bones. And you have traced your place in that whole, from Earth to the solar system, to the Milky Way, to the local group, to the grand web of galaxies, each address reminding you that you are both impossibly small and deeply connected. All of these truths together are not heavy. They are light as breath. They are not burdens, but reminders that the universe is vast enough to hold everything creation and destruction, silence and storms, beginnings and endings, all part of one continuous unfolding. You need not carry the whole of it in your mind. It is enough to know it exists, to let its wonder be a background hum like the stars themselves. As you return to yourself, back from galaxies and horizons into the quiet space of your own life, remember that the universe turns whether you notice it or not. Stars are born, stars die, galaxies collide, and light still travels. And here you are, in the middle of it, safe for now, part of its rhythm, held in its turning. Your breath moves with it. Your heart beats with it. You are carried forward, just as surely as the stars themselves. So let the journey close not with an ending but with a continuation. The universe will go on expanding, creating, remembering whether you are awake or at rest. Tonight, as you drift into sleep, the galaxies will keep spinning, the stars will keep burning, the light will keep traveling. All that vastness, all that time, all those truths you have walked through are still there, waiting, steady as the night sky. Rest in the knowledge that you are part of it, small yet infinite, a fleeting moment and a lasting connection. Rest in the gratitude that the universe has given you not only atoms and breath, but the chance to wonder. Rest in peace, knowing that even as your eyes close, the story continues, quiet and unbroken, written in stars that will keep shining long after dreams have passed.